So let's look at the constant of proportionality. First of all, we should probably talk about what that is. The constant proportionality is the number that is defining a proportional relationship. In other words, it's the number that is multiplying by all of the quantities in the independent variable to get to all the quantities that make our dependent variable, which is why our equation is going to have the form y equals some number times x. In other words, some number times our independent variable to get to our dependent variable. To figure out our constant proportionality, sometimes it's really nice and obvious. In this problem, most of our kids would be able to tell us that we can see that 3 times 10 is 30, 10 times 10 is 100, and 16 times 10 is 160. So if I were trying to figure out the format of my equation and put an x here, well, I know that it's x times 10, or in other words, 10x would be exactly the same way that I move across the table, just as if it was a number. So in other words, I could write my equation y equals 10x. Sometimes, however, the numbers aren't quite as nice to us, and they're not necessarily as immediately obvious. Like in this problem here. It's telling us that the two quantities are proportional, which means that there is definitely that multiplier, that constant of proportionality. But because it's not immediately obvious, we have a few different strategies that we can use. The one that I like to use most is finding that value in the table. So the constant proportionality has another name, and that is also called the unit rate. And as many of our students who take Spanish know, unit also comes from a similar root as the word uno, or one. In other words, if we can figure out the value of y when x is 1, we're going to be able to figure out our constant proportionality. When we do this, I like to look at the 3 rows and figure out just which of those rows has the information that I like best. And I'm going to go with this one because for me, I might as well work with whole numbers. If I don't need to work with decimals, why should I? So I know from this piece of information, I need to somehow get to here. And with proportional relationships, we're always thinking in terms of multiplying or dividing, because multiplication and division, as our students will learn later in the year, are the same thing. So to go from 15 to 1, I can get there by dividing by 15. 15 divided into 15 parts leaves 1 piece in each part, so that works. To create an equivalent ratio, in other words, something that is following the exact same relationship, I need to do the same thing on the other side. It's kind of like working with fractions, where whatever you do to the numerator, you do to the denominator. And I can work with this in 2 ways here. 3 divided by 15, I could work with it as a fraction and simplify it. Whatever I do to the numerator, I do to the denominator, so I can rewrite it as 1/5. Or I could take my calculator and actually do 3 divided by 15 and get 2/10. Either way, I found the value of y when x is 1. Well, to go from 1 to 2/10 though, I know that 1 times 2/10 is equal to 2/10, so that's telling me that my multiplier from the left column to the right column is always going to be 2/10. If we check that with our other values, 8 times 2/10 is 1 6/10, 15 times 2/10 is 3, and 22 times 2/10 is 4 4/10. So it works in every single row. That also is basically giving me my equation right here, that to get my y value, it is equal to 2/10 times my x value, or y equals 2/10 x.